Good morning. My name is Tom Schindl. That off the side. So my name is Tom Schindl. I'm CTO of a small company located in Austria, Tyrol, Innsbruck. I'm a committer at various Eclipse projects, Eclipse for Platform EMF, and I lead the project that does all the JavaFX stuff at Eclipse for the tooling and for the runtime components. My Twitter handle, if you want to follow me, or my blog where I always publish all the news about my work on JavaFX, SWT, you name it in the end. So today we are looking at how we can implement smart code editors on top of the Eclipse 4 platform. And the situation today that we have is that today the current situation is if we want to have code editors, we need to use the Eclipse SDK with the compatibility layer. There is no support in the E4 native platform for providing editor support, auto-completion, all this stuff. This stuff is not there. It's deep down in the SDK or IDE modules or bundles of the Eclipse IDE. And you cannot use that in a pure E4 application. The future situation should be that we have at Eclipse 4 a set of components that you can use to assemble your own smart code editor / IDE in the end. That's the main target, and that's what I'm talking about today. So this component should be loosely coupled. They should be able to run in an Eclipse 4 application. They should run in a pure Java application. In future, they should run in a Jigsaw environment. Everywhere. They should be embedded in NetBeans, in IntelliJ, in Eclipse, you name it in the end. They are loosely coupled components, simply made up of services. That's the main idea behind the stuff. So the first question we can ask ourselves is, should we simply take the stuff that's there in the SDK, in the IDE of the Eclipse platform, and strip out all the references to the compat layer and reuse that? So when we take a deeper look how editors are working at Eclipse, the base part is the editor part, which is really deep down in the compat layer or the 3.x APIs. Out of that is an abstract text editor, and then each editor for each language is subclassing this abstract text editor for the Java editor, for the Dart editor, for the VTB XML editor. All those guys are subclassing stuff. And this goes against the principle that we have at Eclipse 4, where we have one component, and this component is configured using dependency injection from our dependency injection container. So the model that we see in the Eclipse SDK is not suitable to be brought directly to the Eclipse 4 platform. It would run against all the things that we have set up in the last 5 years. So it doesn't make sense to get all the craft back in the Eclipse 4 platform, or Eclipse 4, because we want to have editors. So when we look in an environment like Eclipse 4 with dependency injection and all this stuff, if you look at an editor, it's always the same editor that gets opened. Whether you open a Java file, a Dart file, a JavaScript file, it's always the same text editor. The only thing that changes is the configuration. It has other sets of highlighting rules. It has another auto-completion story. It has probably another outline story. But the editor itself, it's not the Java editor. It's a text editor that is configured to display Java and provide auto-completion. That's the main idea. So an editor mostly is made up of syntax highlighting, error markers, documentation info. If you hover somewhere, then it shows you the Java doc or Dart doc, or you name it in the end, and auto-completion. Those are the main areas of an editor. That's what editor has to do. So this editor that you saw here in the slides, I have it with me. So that's the editor, and it has all the features that we just saw. And this editor is built on the Eclipse 4 platform as loosely coupled components. Well, I'm using in this example as a JavaFX, that's why I can theme this guy. This is done by switching the CSS style sheet. That's a feature that you get when you run with JavaFX. So this is there by default, but for JavaFX, for SJWG, it's a lot harder to do all the theming. But the idea is always the same. So you have one central text editor component, and this guy is configured with services to get auto completion, to get syntax highlighting, error marking. All this stuff is a service. That's the important fact. Okay, back to the slides. Come on. And the first thing that we have to replace is the stuff that abstracts away where we get the content from the file system, from a network drive somewhere. And in Eclipse 3, this is called the iEditor input. And this interface encapsulates your access to a file on the file system, whether it is part of the Neo file system or the Eclipse file system. And for that, we have a replacement called input. Input it's a very small interface. It allows you to get data, to set the data, to dispose, free the resources that you're allocating, for example, for file system locks and all this stuff, and it allows you to persist the content. On top of this basic interface definition, we have a sub-interface called string input, which deals with string inputs. When you deal with text, source code, this is a string representation. And on top of that, there is a source file input, which has some special meanings. Those are interfaces, and on top of that, we have some implementation classes that really abstract it away. For example, if you have a file on the file system, we can use Neo, path, and file to represent that, or in the Eclipse workspaces, we have the Eclipse file system, iFile, iResource, and all this stuff. So this is the abstraction that we are using to abstract away how we deal with the real data or the real file in the end. So the next thing that we need to think about is parsing and highlighting. So the decision that we made is we stay with Eclipse text. Eclipse text is the guy that underlines all your Eclipse IDEs. It's the guy that is responsible for partitioning and tokenizing your source codes and to provide lexical highlighting. And well, it's a fairly old framework. It dates before OSGI was introduced. It's coming from the 2.x area of times of Eclipse, if I'm not mistaken in the end. Well, it shows its ages when you look at the API, but the really cool thing is it performs. It performs so well that it's hard to replace it with something, to come up with something that performs better than Eclipse text. So the first important thing to me, because I'm using it in JavaFX, most of the parts of the text framework are toolkit agnostic. It doesn't care whether you finally render it in JavaFX or SWT or I don't know where. It is toolkit agnostic, at least many parts of it. It does not require OSGI. It can run in an OSGI container. It can run outside of an OSGI container. It does not depend on that. And it is fast. That is important. And it does its job, and it does its job very, very well. And did I say it's insanely fast? And that's important. For a text editing framework, when you do a key typing, you want to see the result immediately popping up in your editor. You don't want to wait for 500 milliseconds to see the character that you just typed. You type it, it has to be shown on screen and highlighted in the correct color. That's the important thing. So, this is an area where people questioned us. Well, there's another control in the JavaFX scene area, which is called rich text area, which is hosted on GitHub, and we have our style text area at the FX Eclipse project. And both of them have a pluggable parser infrastructure for highlighting all this stuff. So when we compare those two frameworks, the difference is only that the visualization controls have the same performance characteristic, but their parser infrastructure is a very naive one. So when you open 10,000 lines of code, Java code, style text 327 microseconds, and rich text 400 microseconds. 150,000 lines of code, 1 second to 3 seconds, and this is on init, opening the editor. I would not care if it takes that long there, but now are the important numbers. When you type a character and you use the Eclipse text parsing infrastructure, it takes 30 milliseconds from typing the key to showing it up on screen. With the native approach that the guys from Rich Text Area are using, it takes 100 milliseconds to show the character. And it really gets a catastrophic area when we deal with 150,000 lines of code. The text framework still 50 milliseconds from key press to key show up in a file of 150,000 lines, code lines in the end. And the other guys, it takes 2 seconds to show up the character. And it sounds easy to write such a text framework, but it's insanely hard to make it perform as good as Eclipse text. That's why we stay with Eclipse text. Just to show you that I'm not making up this stuff. This is a Java file with 150,000 lines of code. Double click, it's opened, scrolling to 150,000 lines of code. That's the performance you get from Eclipse text to do the stuff for you. So, and for example, go up there and start typing. You don't have any delays while you are typing. And that's the important thing when you have a text framework or a text editor. You need to have immediate response. Okay, so let's look, how is Eclipse text able to do that for us? How can it manage to reparse this complete 150,000 lines of code in 50 milliseconds? How do they do that? And they do a trick. They partition their document in certain regions. When you type, they only find out which region is changing, and most of the time it's only 10 lines of code that are really changing, and they have to reparse those 10 lines of code to reapply all the styling and all the theming stuff. And that's the trick that they're using. They start with partitioning, and once they have the partition, they start the lexical highlighting of each partition that you are looking at the moment. And this is done using the iDocument partitioner and the iPresentation reconciler. So when we look at a Java class, for example, what the Eclipse text framework does with it, it creates partitions. The first is a JavaDoc partition, or this is a Dart file. I'm using Dart because with that I get a headless server that allows me to create autocompletion and all the stuff very easy for you. So a comment, another comment, multi-line comment, then we have a string partition, and everything that's not yet captured as a partition is going in the so-called default partition. So this is how Eclipse text looks at your Java file, for example, or Dart file. So it creates partitions, and when you make modifications, for example, in the Dart doc area, it only reparses this partition. It says, there is no change in all other partitions. I don't have to reparse them. I know there's nothing changed in there. So that's the trick that they're using. So how do you do partitioning? Well, it's fairly simple for Dart or Java to set up rules. For example, a Dart doc slash asterisk asterisk, it's multi-line and ends with asterisk slash. A comment single line starts with slash slash until the end of the line. Multi-line comment slash asterisk, string with and a character. These are the rules that we make up to create the partitions in our document. Very, very simple rules. And to implement these rules in Java code, there are some base classes that the Eclipse text framework provides to you. It's a so-called single line rule or a multi-line rule. The trick is a single line rule has a start sequence, slash slash, for example, but it doesn't need an end sequence. So it's null in this case. And we have a multi-line rule that, for example, starts with slash asterisk and ends with that. And you assign a so-called token to each of these rules. So when the document is partitioned, you get a partition that is named Dart SL comment, Dart doc comment. So that's the idea behind the framework. So now it gets quite tough because we have the rule. Now we need to configure the partitioning, and this is stuff that I have on the slides, and I will go through it very quickly. because this is something that we are going to replace in the next step through a DSL. But this is what you need to know when you would set up Eclipse text yourself. So to do the partitioning, you have a fast partitioner. The fast partitioner delegates the real work to a iPartition token scanner. And this guy that is a default implementation there is the rule-based partition scanner, which takes the rules that we just met up in our table. You need to remember that all the time when you write an editor in Eclipse. So this is how the code will look like. You have a rule-based partition scanner, you have some rules that you set up, and in the end you create a fast partitioner, tell him what are the partitions in my system, that's it. But you need to remember that, and you need to write a whole lot of code to get Eclipse text configured. So instead of remembering that, when we go to the next slide, this is an area where a DSL makes a whole lot of sense. I don't want to know all the infrastructure stuff of Eclipse text to write syntax highlighting for my preferred language. I want to express it in a very short syntax. And this is a DSL that we made up. And this is how you define the partitioning of a dot file in the DSL. So you don't have to remember all the stuff that comes with Eclipse text. You just need to use an editor without the completion to edit this file, and you can partition your documents. So after we have partitioned our document, we need to look at each partition and tokenize, find out all the keywords and all the other stuff in there. So this is the lexical highlighting phase or tokenizing phase. So when we look at our file, we have the Dart doc, which has no, well, it's one big region. There is no keyword in there, nothing in there. But when we look at our default area, we find out that we have a token that starts at character position 27 and goes until character position 31, which is the class keyword. So we made them make it verbal in the end. The same is true for public, for example, another token. So in the second pass that we do, we go through the partitions and find out all individual tokens that are found in there and remember where they are in the document. And all that is not part of a specialized token goes to the default token. All black stuff in the end is default token area. So for tokenizing, we have the same set of rules that we used already for tokenizing or for partitioning, plus some extra rules, for example, a rule for words for keywords that allows us to identify keywords very efficiently. There's a rule that identifies characters. For example, if you want to identify all the operational characters like plus, minus, there is a special rule for that. There's the single line rule that we already found out and the multi-line rule that we already know about. Once more, same story. A lot of things that you have to remember to get the system in a state that it can do all this highlighting and reconciling when you start editing. You need a presentation reconciler. The presentation reconciler pushes all the work to a so-called iPresentation damager and iPresentation repairer. There's a default implementation there, which delegates once more to a token scanner, and there is a rule-based token scanner that can deal with our rules. Need to remember all the stuff all the time. So this is how it would look like in Java code when you set up all the scanner rules. Important information is up here. We will find out what this means. A text attribute has start, dot, default, dot, keyword. What that makes up is quite interesting. You see here how keywords are specified in this type of thing. And then when you set up the damager and repairer stuff, that's the Java code. This is what you would need to remember all time when you set up editors and do that with Java code. So, but we have this DSL. Now we expressed in the first part of our DSL, we expressed how the partitioning is working. In the second part of the DSL, we define how a partition is split up in tokens. And this is how it would like for our Dart language, for example. So you have, for example, Dart keyword with the keywords, and then you have a list of keywords. You don't have to remember all the internals, how to set up combined word rules and all this stuff. This is the DSL that expresses really exactly what you're up to. Okay. Once we have all this information about the tokens, we need to represent them visually on the screen. And this is where the Dart, the text attribute that we see up here, is important. Because when you look at style text area, or it's made up of style text nodes, it takes these guys as class selectors, which you can reference in a CSS style sheet. So we assign to all tokens CSS classes, and then we apply a CSS style sheet that takes all the tokens and highlights them in a special syntax. For JavaFX, you have a special feature. You can reference general predefined colors that you made up yourself in CSS. This is something that you only get with JavaFX. So just to show you how that works in reality. So we have this guy we can close. This guy as well. And so this is our editor, but at the moment it misses for num is an built-in type in Dart, in the Dart language, so we want to highlight this built-in type as well. So when we go for that, when I open the correct Eclipse, the first thing is that we need to go into our definition file and add another rule of type keywords, and there we have the num as a keyword. That's the first thing that we need to do. So we have now made up the rules for lexical highlighting in a certain region and say num is a special thing there. The second thing that we need to do is we need to go to the CSS style sheet that defines all the highlighting stuff and turn in there the syntax coloring for this special type. This is all that we need to do. So it's always we have the name here, those names, they match. This name matches to this name that we see here. That's the trick that we are using. So, starting once more, this guy opens. And we have highlightings for num in here, because we made up the rule for that. Okay, so how does the integration in Eclipse 4 work? Well, we have the Java VM at the low level, then we have OSGI, then we have the Eclipse 4 application platform, and by default, when you get Eclipse 4, you use SWT as a rendering framework, and then you write your application code. What we do at FX Clipse is we drop out the SWT layer and drop in JavaFX support in here. That's the trick. And in this area, we have our text editing framework moved in here so that you can write text editors. Integration is done in Eclipse 4 with a so-called type provider service, which is a very, very cool thing in the end. The trick is that when we look at the system, this is the interface that we have internally. It's called type provider service, and there is a subclass input dependent type provider service, and the real provider service is document provider type provider. So when the editor opens, it has an input of a Java file, a Dart file, and with this guy, it goes out and says, okay, this is how it looks from the dependency injection container side of the view. The dependency injection container asks the iEclipse context for a type of iDocument partitioner. This type is not there, there is no value there, but there is a context function that deals for this value. And this context function goes off to the OSGI service registry and searches all services that are registered who can provide a type for new source file. That's the input file that we are just looking at. So that's the trick that we are using internally. We are delegating all the stuff through. And this is what we do for the partitioning, for the highlighting, for the auto-completion, for everything in the end. That's the main idea. Okay. So in code, it looks like this. You have a document partitioner. You see the add component annotation up here. This is generating the XML files, the contribution or the DS stuff for us. This is how it looks for the document provider, and for the presentation reconciler, it's completely the same story. It's always the same. All the stuff is contributed to this in this way to the framework. So when we look at autocomplete, there's a certain trend going on in our industry. When you look at Dart, TypeScript, Go, Rust, they all provide headless servers for autocompletion. You don't have to program that yourself in your IDE. You can reuse their server infrastructure. For the Dart SDK, the nice thing is they ship it as part of the SDK. So if you get Dart, that's why I'm using Dart as a sample, because then you can replay or make up the stuff that I show here on stage yourself. But that's a certain trend that's going on in the industry. You have code servers in the end that do all the work for autocompletion, error reporting, and all the stuff for us. So the Dart server has two interaction types. When you start a Dart server, you communicate with it from the input and output stream. You send him a JavaScript object notation message, and normally he responds with another message. So when I set up the sample that we saw here, we send this information to the Dart server and tell him where is our source directory. And at the point when we need autocompletion, we send him the information. We need autocompletion at the offset in our file at offset 367. And the Dart server asynchronously responds to us with all the autocompletions that we would like to show at this point in the UI. So we have written a Java API on top of that, so they don't need to craft all these messages yourself. The interaction looks like this. You get a Dart server instance, you get some services, you set the analyzing route, and you call out for the autocompletion story on the Dart server. And the Dart server will asynchronously at some point in time respond with all the autocompletion that it found at a certain position. So I think we don't have time to show that in, well, we have, well, bit of time we have still. So autocompletion is implemented in our story with the proposal computer interface, which is a very small interface. Once more, if it's not there, you don't have autocompletion. For example, the editor, or the editor in our case that we made up here still has no autocompletion. So doing control space, nothing is happening. But that's okay for editor. It just opens, shows syntax highlighting, doesn't have autocompletion, but it has error highlighting, for example. Because all those services are optional. If it's not there, it's not there. Then we show the text in black if there's no highlighting available. No problem at all in the end. So for autocompletion, what we need to do is we need to register the autocompletion service in the OSJ service registry. And that's done by, if I open my to-do list, register the autocompletion. So all we need to do, register this guy in the OSJ service registry, and on the next launch of the application, we get autocompletion in the editor. It's just that the service is there, and it's there, it's there. It provides autocompletion. If it's not there, it's not there. Those are all loosely coupled components. If something is there, it works. If something is not there, you don't have the feature. Okay, that's the main idea. Okay, autocompletion. I've skipped now the arrow highlighting so that we have time for questions. And show you that because all this stuff is so loosely coupled, well, until now I've shown you all the stuff running in an Eclipse 4 application. But up here, not here, I have an application that's a plain Java application configured using a Maven BOM. It points to, well, we are publishing our stuff on Maven Central, so you can create a ordinary Java project in your system. Add the Maven infrastructure, reference our editor component, and out of that you get an editor. This is now plain Java, no OSGI involved, which has the same feature set that we saw on the server that was running in OSGI. This is when I always talk about don't make your components depend on the framework. because then you can use them everywhere. And if you use dependency injection to get everything configured and set up, you are not bound to a certain framework like Eclipse or another one. So this is the key point that we have. And a very interesting last stuff is most of our services and most of our infrastructure for this editor component is built in a way that it doesn't depend on JavaFX. So I can reuse all the infrastructure. For example, the LDAF file, I have here an SWT application with an editor. Open the editor. That's an Eclipse 4 application running on SWT using most of the text infrastructure that we have plus our DSL to specify that a Dart file should be highlighted this way. This is now no JavaFX, this is not SWT. But all the components are loosely coupled once more. Well, there's no JavaFX, but there's SWT who can do the displaying for us. Perfect. We use SWT, no problem. And all the other components at the low level with the auto-completion, all this stuff is still there. So that's the main idea behind all the stuff. So we have, at the moment, we have syntax highlighting for various languages, starting from ASCII-Doc to Ceylon, Dart, Go, Groovy, Java, JavaScript, Kotlin, Lua, PHP, Python, Rust, Swift, XML. We have internal research for TypeScript. Autocompletion, we have open source. We show you how you can do that with Dart. We have internal prototypes running with Java, JavaScript, and TypeScript. And for outline viewing, we have open source a Dart outline where you can show that with Dart so that you can try that out yourself. And internal research prototypes for Java, JavaScript, and TypeScript. That's the main idea. So if you have the problem of creating a specialized IDE for your product, our components are very well suited to get incorporated in your product. And that's the main theme that we are trying to provide to you, components that you can reuse to write your own small IDE or smart code editor. That's the idea. Okay, thanks for listening. Time is up. Are there any questions out there? Did I overwhelm you? So with all the freaky stuff going on, it's okay. Thanks for listening and have a good day.